Okay, this is the last question of paper two, September 18th, Saturday workshop. We're going to look at these last geometry questions. They ask us to prove that triangle ACP is similar to triangle CBP. This is what I do. I go from A to C to P, make sure I've got the triangle. It's this big green one here that I've outlined. And then from C to B to P, C to B to P, that's this little red triangle that I've outlined. We're going to prove they're similar. Well, we've got something with the big green triangle and the little red triangle. They share something already. Angle P is common. Angle P is common. So we've got one angle right there. We just need one more. Okay, well, I think C1 is X, and we already showed that A was X because of the tan chord theorem in previous questions. So C1 equals A equals X. Hey, we've matched up A and C here. A and C1, we have P being similar, P being the same, congruent, because it's a common angle. Well, the other angle, because of angle sum in a triangle, also has to be equal. Therefore, triangle ACP is similar to triangle CBP. Well, we proved they're similar. Let's try now. The next one is a little bit harder. Now, we're going to use this similarity to do this question. Now, I can see they've done this thing with PA and PB. Well, there's PA. PA is in there a little bit. There's goes with PC, it looks like. PA goes with PC, but then PC could go with CB. Well, we could get PC in there twice, and we can get the PA happening. PA happening. All we have to do is we make fractions out of the sides of the triangle. Oh, look at this. PC, this PC here goes with PA here. If two triangles are similar, their sides are proportional. So we can go PC goes with PA. But hey, we can go PB goes with PC here. PB goes with PC. Okay, we've got that. All right. PC goes with PA and PB goes with PC. Hey, there's our first fraction. Why can we do it? It's because similar triangles are proportional. Maybe I should have written proportional here. But now, hey, if we cross multiply here, we get PC squared equals PA times PB. Well, at least we've got a way of looking at PA and PB. Let's go take a look at where PC is. Oh, there it is. Wow. If it was a right angled triangle, we could do this thing. It looks like Pythagoras, squaring two sides or subtracting or adding. There's probably Pythagoras happening here. Oh, yeah. And then you go, what? This is 90 degrees plus X. But if C3 is X, this other part's got to be 90 degrees because we know that ACP or CTP equals 90 plus X. So that's the big deal. We can show this is a right angle triangle, and that's what we do. We go OCP, this angle here, OCP must be a 90-degree angle. Why? Because PCT, which is 90 plus X, if we take away this X, we're left with the angle OCP. So OCP is 90 degrees. Well, that means we've got a right angle, and we can use Pythagoras. So now we can say this side squared, which is the short side, equals the hypotenuse squared minus OC squared. Oh, we almost have it. OP squared minus OC squared equals the PC squared. Okay, we've got that. That's what PAB equals. It equals this by Pythagoras. One last thing. Hey, they've got OA here instead of OC. That's okay because OA and OC are radii. They're equal to each other. Therefore, OP squared minus OC squared. Therefore, I wanted to say OA squared. And then the last thing, we can put in OA squared and get our answer. So what we want right here is OA squared. Therefore, we get our answer because OC is really equal to OA. We can put in our last answer, which is OA squared. So let me just put that in OA, and then we'll make it squared. And there's the last thing put in there that's going to make it right. P squared minus OA squared equals PA times PB. You see, because those C and OA are the same, I can rub out the OC and put OA, and I get the final thing that we were supposed to prove. Ooh, that was a little bit tricky. I had to use similarity to get proportion, and then I had to get this cross multiplying to get a square thing happening. Then I had to look for a right angled triangle because it must be Pythagoras. That was a little tricky. That's the last question. Okay.